Hey everyone, welcome to the lecture series of Elementary Classical Mechanics where we will embark our journey from basic to advanced physics. This is lecture number 3. This time we deal with derivative formula for the part 2 of this series. For theoretical viewpoint, please watch my previous lecture on overview of calculus derivatives. Or if you are familiar with the theory of the derivative, you can continue this video. Calculus is must to understand. That's why we must know how to use it. In this lecture, I will explain how to use various formulas of derivatives on functions. I recommend you to take notepad in order to take notes and solve the examples. So without further ado, let's get started. First, we must get familiar with the functions. The functions are the equation consist of constants and variables. Constants are numbers which will not change. For example, if there is a constant a equal to 2, the value will not change throughout the problem. Where the variables are which can change throughout the problem, and due to their change in variables, the functions will change. Here is a general formula of the function which also called as polynomial, in which there are constants and variables. Y of x equals to a0 dot x raised to 0 plus a1 dot x raised to 1 plus 2 dot x raised to 2 plus till a n dot x raised to n. This equation will continue till n number. In this equation, all the constants are a's and all the variables are x's for degrees from 0 to n. One of the examples, the function is written as y of x equals to x dot, which has a constant a and variable x. Similarly, for the new function, a new name z of x equals to c plus b dot x plus a dot x square, where a, b, c are constants and x is a variable. See, in the function, you can change the name. The function can change their name, but the function will depend ultimately on the variable x. Or you can, in that case, you can take any other variable also. But you need to fix the variables, the constants, and the function name to form a polynomial. Therefore, we need a function which consists of constant and variables. Now you are familiar with the functions, let us continue to the derivative. There are various forms of derivatives, homogeneous, non-homogeneous, etc. Since we are in the basics, taking them will be the invitation to the confusion. So I will take only the following. The first form you see is the simplest form of derivative. Derivative of y with respect to x, or simply you can call them as dy by dx. And if you find the derivative of the simple derivation, you will get the double derivative or second order derivative in more technical sense, d square y by dx square. Now let us understand the formulas. If we need to find the derivative of function x raised to n, then it will be n dot x raised to n minus 1. And if there is a function k dot x, where k being the constant, then k constant will remain outside the derivative operated on just x only. And eventually we will get the result as k. Yeah, when you face with any constant in the equation, you want to find the derivative of the function, then all the constants remain outside the derivative. For the trigonometric function for a sin x, where x being the angle, then its derivative will be cos x. And if the derivative is applied to cos x, then we get the negative of sin x. And if you still do not have the notepad, it's time to take out. Let's go through an example. Let us let us first do the derivation of the simple function f of x equal to 6x square. Now we find the derivative of this function such as d by dx of f of x is equal to d of dx of 6x square. Now, from the rule, we know that the now 6 is a constant, so it remains outside, and we simply only find the derivative of x square. Now using the formula d of dx of x raised to n equal to n dot x raised to n minus 1, then we get 2 dot x raised to 2 minus 1. Therefore, we get 6 multiplied by 2 multiplied by x raised to 1, or simply as x. So the final form we get is 12x. Now take another function. This time you do it yourself. Remember to have the notepad with you. So first find the derivative of this function f of x equals to 7x. Now we know that 7 is a constant. So if we find the derivative of d of dx of f of x equals to d of dx of 7x. 7 is a constant, so it remains outside. Therefore we get 7 dot d of dx of x. So by using the same formula x raised to n, that is d of dx of x raised to n, we get d of dx of x as 1. So d of dx of this function 7x is 7. Rules of algebra in derivative for addition and subtraction is given below. Therefore, we take two functions u of x and v of x, which means that function u and v depends upon x variable. So as the x changes, the function u and v changes. We simply call them as u and v, for convenience. And we have the sum and differences of those two functions. When we find the derivative of sum, that is d of dx into the bracket u plus v is d of dx of u plus d of dx of v, or simply as du by dx plus dv by dx. Similarly, when we find the derivative of difference, that is d of dx into the bracket u minus v, we get du of dx minus dv of dx. Let us understand the sum and difference rule by an example. So first we take the function f of x equal to 6x plus 2x square plus 1. Remember, I forgot to say that whenever I say to find the derivative, I mean is to find the derivative of d of dx. I need to find the derivative of this function with respect to x. Okay, please remember that. That is very important. So d of dx of this function equals to d of dx of 6x plus 2x square plus 1. We write in separate form, we distribute it. After that, since 6 is a constant, so 6 remains outside. So d of dx of x plus d of dx of 2x square will be 2 dot d of dx of x square. Since 1 is a constant, therefore there is no differentiation of that, therefore it is 0. Remember, the differentiation of any constant is 0. Dx of x will be 1, so 6, just 6 plus 2 multiplied by 2 dot x raised to 2 minus 1 by using the formula, and finally we get 6 plus 4x. So that is the derivative of the function. The derivative of the function 6x plus 2x square plus 1 is 6 plus 4x. Here the formulas gets little complicated in derivative. Again we use the same two functions u and v, but now this time we find the derivative of the product of these two functions. So d of dx of u dot v equals to v multiplied by du by dx plus u multiplied by dv by dx. The procedure is such that we first find the derivative of u by keeping v outside. for this instant by keeping v constant, plus find the derivative of v by keeping u outside, for this instant keeping u constant. Try using this product rule to y equal to kx by differentiating with respect to x. Now let's move on to the examples. Now let us take an example for product rule. F of x equals to x squared multiplied by cos of x. Now let us choose x square as u and cos x as v. It is important to choose before solving this kind of example, u and v. Now using the rule v dot d of dx of u plus u dot d of dx of v. So replacing the variable u is cos x and x square, we get the following. Now x square is 2x according to the rule of derivative of x raised to n, and cos x is minus sin x. Now arranging properly, we get the final form as 2x cos x minus x squared sin x. Now we use the same functions u and v by dividing them, such as u by v. For this kind of case, the derivative is operated such that d of dx of u by v equals to v multiplied by du by dx and minus u multiplied by dv by dx, and then dividing whole thing by square of v. It is difficult to remember this formula, but the trick is that first find the derivative of numerator by keeping the denominator outside, minus reverse the first procedure, such as by finding the derivative of denominator by keeping outside the numerator, just like we did in the product, except the minus sign. Then finally divide the whole thing by square of v. Let us understand by an example. Now in this case, let us take the function f of x as x upon cos x. First decide u is x and then cos x is v. We know that formula of division rule is d of dx of u upon v is v multiplied by d of dx of u minus u multiplied by d of dx of v, dividing whole by square of v. Now substituting the respective values of u and v's, such as u is x and v is cos x. Then we know that d of dx of x is 1 and d of dx of cos x is, according to the rule, is minus sin x. Then we properly arrange them. Now writing, we get the simplified form. Again simplified form, and also tan x is sin x upon cos x. Henceforth the answer. Now what happens when there is another variable in the function? For example, if f of x equals to sin theta, then let us take derivative of f of x such that d of dx of f of x equals to d of dx of sin theta. See, theta is a variable such as x square or sin x instead of theta. Then for finding out the derivative, we should find the derivative of theta variable separately. So first, derivative of sin theta is cos theta. We simply find the derivative of the function sin and then find the derivative of the variable theta. Let us understand by an example. Let us take a function f of x equals to sin x square plus x cube. Then now first find the derivative of sin x square, then x cube by using the sum rule. First simply find out the derivative of sin theta. In this case, sin x square. So sin x square is cos x square after derivative. By formula, d of dx of sin x is cos x. Then we find the derivative of x square with respect to x plus derivative of x cube according to the formula d of dx of x raised to n is n multiplied by x raised to n minus 1. Therefore, we get 3 multiplied by x raised to 3 minus 1. And finally, we get the result as 2x cos x squared plus 3x square. So, this is how we apply the chain rule for different types of examples. So, in such functions, we'll have to follow this chain rule. I have a link in the description for NCERT book. That is the official website for NCERT, which you can download the PDFs or ebook of NCERT. Please go through the website and download the books on maths of 11th and 12th standard. There they have given bunch of examples and formulas. Please practice those. You will not understand maths without solving. Solve as much as you can.